This video tutorial shows how to get started with AnTracks. It's meant to show the basic usage, so we take a very simple toy application and use AnTracks to track Pacman. The video is actually longer than necessary, so let's just select the time window from frame 400 to frame 600. One of Pacman's most striking characteristics is that he is pretty yellow, so let's use that feature for tracking and select the color matching method. We can now either select a color from the dialog or pick one from the image. We do the latter by clicking on Pacman. The processed view now shows the color difference between the color we are tracking and each pixel in the video. As expected, Pacman himself has the lowest difference to yellow, so he's the darkest spot in this view. Let's invert the signal so that Pacman is the brightest spot now, because he's the closest match to the yellow color. We add some Gaussian blur. The color gradients look a bit ugly in the ampere compression, but that's only the video. As you can see in the current object stats panel on the bottom, Pacman has an intensity of around 120 to 160 here, and the background is in the range of 20 to 30. So let's threshold the image with a value of, say, 100. What remains is Pacman, but also some other blob, which is the large Pacman graphics out at the playing field. In a real-world application, this could for instance be some reference marker in your video. We don't want to track that, so let's exclude that area from processing. And let's also exclude the other region on the right side. These areas are now excluded from processing. When you activate the exclusions view, you see that they are dimmed out. We can now start the tracking. You can see that AnTracks detects Pacman's position in each frame and tracks his movement. At the end, 201 blobs have been found, so one in each frame reprocessed, and they are all in one continuous trajectory. Let's try something else. Instead of just tracking yellow Pacman, we now want to track also the ghosts, so essentially everything that moves. For that purpose, we choose the frame differencing method, which detects motion. We reset all data and start from scratch. In the processed view, we see 6 signals now, Pacman and the 5 ghosts. They all have a signal intensity of around 50 to 70, so let's blur again and set a threshold for the signal. Let's choose 30. When we start tracking now, you see that Pacman and the 5 ghosts are being detected and tracked. But there's also something else. There are 2 special pills on the right, which grow and shrink, and those changes are also detected by the motion detector. Let's take a closer look at them. So here they're small, and here they are large. Their blobs have a size of about 35, as you can see in the current objects states panel on the bottom. If you point the mouse on a blob, that blob size is also highlighted in green in the histogram and the spectrum. Those small pills have a size of 35, whereas Pacman and the ghosts are in the range of 220 or 240. We can use that size difference to filter out the unwanted signals from the pills. Simply activate the blob size filter. The thresholds of 100 and 500 are already fine. When we start tracking now, the 2 pills are not detected anymore, but only Pacman and the ghosts. Pacman and the ghosts are successfully tracked and their trajectories recorded. We can save the blob data and the trajectory data now to files for further analysis. This video tutorial has demonstrated a very simple application of AnTracks to track Pacman and the ghosts. The techniques shown here can be applied for real tracking applications. Instead of Pacman, you could imagine tracking fluorescently labeled cells or moving animals, for example. For more advanced applications of AnTracks, check out the other videos.